12.5 and 12.6 have been lumped together. And I'm going to kind of go out of order. So here we have a quadratic equation. It wants us to solve by completing the square. So I'm going to move the 39 to the other side. X squared plus 14x, leave a space, equals negative 39. And my perfect square is going to be x plus half of this. So 7 squared. And x plus 7 times x plus 7 is going to give me x squared plus 14x plus 49. And that's the number that completes the square. But if I add 49 to the left side, I also need to add 49 to the right side, not 14, 49. And that gives me a 10. So this is x plus 7 squared equals 10. And then I take the square root, and I get x plus 7 equals plus or minus 10. So we subtract plus or minus the square root of 10. And then we subtract 7. So x is negative 7 plus or minus root 10. And you'll need to plug those in your calculator to get the answer. Negative 7 plus root 10 and negative 7 minus root 10. Okay. Well, what if this was, say, negative 9? What happens when I square root negative 9? I get plus or minus 3i. So your answer is going to be negative 7 plus or minus 3i. And this is the whole reason why you have studied imaginary numbers. Where do you graph negative 7 plus or minus 3i on a coordinate plane that only uses real numbers? And the answer is you can't. So this quadratic, if this ended up being negative 9, that quadratic is going to miss the x-axis. So we asked, where does this equation equal 0? And the answer is, it doesn't. So there is no real number answer. Okay? All right, let's do, okay, let's do this one. Ooh, that's kind of ugly. Let's not do that one quite yet. All right. Let's say I had the equation y equals x squared minus 5x plus 6. And I wanted to graph it using the vertex. So I need to complete the square, but instead of moving 6 to the other side, I'm just going to move 6 out of the way. So y equals x squared minus 5x, leave a space, plus 6. So y equals x minus something squared. What is that something? Well, it's half of negative 5, which is 2.5. But we learned in the last lesson, don't write 2.5, write 5 halves. So I put a 5 over 2 there. And the reason we do that is 5 over 2 is really easy to square. It's just 25 fourths. And if I add 25 fourths to this side, now the right side is heavy. So I need to subtract 25 fourths to make the equation balance out again. 6 is also known as 24 fourths. So 24 over 4 minus 25 over 4 is minus 1 over 4. Does everybody get that? Or are you confused? Well, no. What part did you get stuck at? It's about to get a lot harder, so you make sure that you understand this piece. Yes. So when we complete the square to solve, so if I wanted to solve this for x, for y, when y equals 0, So we would move, oh, let's do this. We would move the 6 to the other side. We would get x squared minus 5x, leave a space, equals negative 6. And then we would get x minus 5 over 2 squared, and then this would be 25 over 4, but I need to add 25 over 4. And that's going to be 5 times 5 over 2 times 2. Yeah, I just squared this. And then here I would take the square root, and I would get x minus 5 over 2 equals plus or minus 1/2. And then I would add 5 over 2, and I would get 1/2 plus 5 over 2 is 6 over 2, which is 3. And then negative 1/2 plus 5 over 2 is 4 over 2, which is 2. So this piece here is what we do to get the roots, 3, 2. Okay? And then we use the same sort of process, but here I want to know what the vertex is. So in this one, I was asking, where does the graph hit the x-axis at 2 and at 3? But over here, I want to know, where is the vertex of the graph? Okay? And we have to complete the square, but instead of moving the 6 to the other side, I'm just going to move the 6 out of the way because I always want y by itself when I'm graphing. So when I move that 6 out of the way, and I add my 25 over 4, now the right side is heavy. I could put 25 over 4 on the other side, but I want the y by itself. So I'm just going to subtract 25 over 4, and this has a net effect of 0. It allows me to dress up the equation in the way I want to, but the balance is the same. We added some and subtracted some from the same side. So this chunk turns into that, and this chunk turns into that. And why would I do that? Well, I now know that I need to go right 2.5 and down 0.25. So to graph this, I go right 2.5 and down 0.25. Okay, does that help? Does that make more sense? No? Okay. We better do another one before we do the hard one then. Okay, so y equals x squared minus 10x plus 9. So I want to know what is the vertex? So I bump the 9 out of the way. Y equals x squared minus 10x, leave a space, equals 9, not equals 9, plus 9. So my perfect square is x minus 5 squared. Okay? Well, if this is my perfect squared, it's half of negative 10. And then what number would have to be there in order for this to factor into x minus 5 and x minus 5? That number would have to be a 25. And if you look at this, if you try to factor it, two numbers that multiply to be 25 and add to be negative 10, it would be x minus 5 and x minus 5. That is what we mean by complete the square. I turned a quadratic that may or may not have factored into a new quadratic that factors into two identical binomials, x minus 5 and x minus 5. And what's the pattern? To create that, we cut this in half, and then we times that by itself. And that is the same pattern you're going to use every single time you complete the square. But this makes the right side too heavy. So I can either add stuff to the left to balance it out, or I can subtract stuff from the right to balance it out. Which one do we want to do here? I want to take away that 25. So I'm going to subtract 25 here. And now I get minus 16. And I've just converted from, we call this standard form, into vertex form. So where would that be? Right 5 and down 16. That's what the parabola would look like. Okay? So, in the form specified would be y equals x minus 5 squared minus 16. What's the vertex? 5, negative 16. And then I would graph that on here. Okay, before it gets tough, do you want to see another one? Yes? No? Yes? Okay. Y equals x squared minus 3x, let's say minus 40. Okay. So I want this in the form y equals x something squared. Okay. So I need to move the 40 out of the way. Leave a space, minus 40. So from this number, what's going to go in my perfect square? What? 1.5. But we don't want to write it as 1.5. We want to write it as 3 over 2. So minus 3 over 2. Okay? If it's negative x squared, we're gonna do something more complicated. So we're not ready for that yet. That's one of the hard ones. So if this is negative 3 over 2, what goes there? Negative 3 over 2 times itself, which is going to be plus 9 over 4. Does everybody get that? But if I add 9 over 4 on the left side, I need to take that 9 over 4 off of the right side. 40 is also known as 160 over 4. So negative 160 over 4 minus 9 over 4 is negative 169 over 4. So where is the vertex? Right, 3 over 2, and down 169 over 4. Okay, does that make sense? Okay, any questions about that? Because it really is about to get harder. We're good? Do you want to see another one? Right, that's the hard one. So, are you ready to do the hard one? Okay, well, let me do one more. So y equals x squared minus 12x plus 20. So y equals x squared minus 12x, leave a space, plus 20. Okay. So this is x minus 6 squared. So this would be a 36. And if I add 36 here, I need to subtract 36 there, and I get that. So the vertex is right 6 and negative 16. So the x, in transformations, the x always works backwards. Right? So if I had the absolute value of x plus 2 minus 3, I would take the normal absolute value graph, and I would move it left 2 and down 3. That's how transformations work. The stuff on the inside always works backwards. Do you remember that? Okay. Now, when I graph this one, I would go right 6 and down 16, right here. And then I need to plot 5 points. So a parabola is right 1, up 1, left 1, up 1, and then left 2, up. Do you guys remember? So if we had x and y equals x squared, 0, 0, 1, 1, negative 1, 1. But if I plug in 2, I get 4. And negative 2, I also get 4. So the pattern of a parabola is over 1, up 1, over 2, up 4. Over 1, up 1, over 2, up 4. Because 1 squared is 1, but 2 squared is 4. So to graph a normal parabola, you go over 1, up 1, and over 2, up 4. Okay. Now, pay close attention to this because it's about to get weird. So my equation is y equals 2x squared plus 4x minus 3. Now, I need to move that 3 out of the way just like I did before. So y equals 2x squared plus 4x, leave a space, minus 3. But I can't complete the square unless the number in front of the x squared is a positive 1, which in this case it's not. So I need to factor out a 2. But if I pull a 2 out of this, I also need to pull a 2 out of that. So y equals 2 times x squared plus 2x, leave a space, minus 3. Everybody get that? Okay. Now I keep going. 2 times what's going to go in here? So what's the pattern to go from here to here? Divide by 2. So this will be x plus 1. And then what's the pattern to go from here to here? Square it. So plus 1. Well, if I add 1 to the right side, what else do I need to do? Subtract 1. However, this is not a 1. We wrote down 1, which is correct. But I did not add 1 pound to the right side. What did I actually do? Well, that 1 is sitting underneath a 2. So by putting a 1 on the inside of that set of parentheses, I actually added 2 pounds. So to undo those 2 pounds, I need to subtract 2 there. And then this becomes minus 5. Okay, that's the first tricky thing. So my equation is y equals 2 times x plus 1 squared minus 5. Where is the vertex? Well, what's the x coordinate of the vertex? Negative 1. And the y coordinate of the vertex? Negative 5. So on my graph, I go negative 1 and negative 1, 2, 3, 4, 5. Normally, I would go over 1, up 1, over 1, up 1. But this parabola is twice as tall as normal. So instead of over 1, up 1, I'm going to go over 1, up 2. Over 1, up 2. And then I'll go over 2, up. Normally it's 4. But in this case, it's going to be twice as big as 4. So over 2, up 8. Over 2, up 8. And this parabola is going to be taller than your regular parabola. Okay, let's do another one. Here's a negative. Yes, it will be different. So y equals negative 2x squared plus 16x, leave a space, minus 25. So when I complete my square, I need this to be x plus, or I guess it could be minus, x something squared. Okay? So I need to yank out a -2 from each of these. So y equals -2 times what's left? X squared. And what happens when I take a -2 out of 16? It becomes -8x, and then this is still unknown, minus 25. Okay? So there's a -2 here. And then everybody else good? So what goes in the perfect square? -4. And if this is a -4, what goes up here? 16. But did I really add 16 to the right? What did I actually do? I added -32 because that 16 is hiding underneath a -2. So to undo that 16, I need to add 32. -2 times 16 has a net effect of subtracting 32. To undo that -32, I need to add 32. And then this becomes plus 9. So where is the vertex? 4, 9. So if I graph this, I go right 4 and up 9. Now, normally I go right 1 and up 1. But with a -2 out front, I'm actually going to go right 1. So my normal parabola is right 1, up 1, and right 2, up 4. Like that. And that is when the leading coefficient is a 1. But what if the leading coefficient is a -2? Well, now it's right 1, down 2, and right 2, down 8. So my new parabola is twice as tall, and it's upside down. So right 1, down 2, left 1, down 2, and then right 2, down 1, 2, 3, 4, 5, 6, 7, 8, whatever that is. Does that make sense? Okay, it's about to get harder, so do you want to see another one? I'm not going to do yours. Okay, I'll show you again. Let's do another negative one. Okay. So y equals -3x squared plus 30x, leave a space, minus 74. I need to pull out a -3. So y equals -3 times x squared minus 10x, leave a space, minus 74. Everybody good there? Okay. So y equals -3 times x minus 5 squared. And then we still have a -74. But if this is a -5, what goes there? 25. So this is plus 25. But that's not really a 25. So this is where you were getting hung up. Do you see why it's not a 25? I think what you're trying to do is your work and this at the same time. And that's why you're confused, because you're not paying attention. So this number is correct. 25 does complete the square. But I did not add 25 pounds to the right side, because that 25 is hiding underneath a -3. So the true value of that 25 is -75. Does that make sense? So if I were to multiply these in, then I would get negative 3x plus 30x squared minus 75. So if I add if I take away 75 on this side, then I need to add that 75 to this side. Otherwise, I'm unbalanced. And so this just turns into a plus 1. Does that make sense? Are you for real this time? Okay. So where is the vertex? 5, 1. Right? Okay, don't get started on your stuff again because it's going to get harder. So the vertex is 5, 1. So I go out to 5 and up 1. And then how do I graph this one? Over 1. Normally it's over 1, up 1. But this one is going to be over 1, down 3. And then over 2, down. Normally it's over 2, up 2, or over 2, up 4. But this one gets multiplied by negative 3. So it's going to be over 2, down 12. And that's what it'll look like. Okay? All right. Okay. So please pay attention to this. Don't, whatever you're doing, stop and do this. Here I want to know the minimum cost. So this is some upward opening parabola, and I want to know where the vertex is. So we build a certain number of machines, and we get paid a certain value according to how many machines we build. What is the minimum amount we can get paid? So my equation is y equals 0.9x squared minus 414 plus 65441. So I'm going to move this out of the way, and I'm going to pull out a 0.9. So y equals 0.9 times x squared minus whatever 414 divided by 0.9 is. So 414 divided by 0.9 minus 460x, leave a space, plus 65441. Does everybody understand that? We're good? What? I'm not done. No, we're not done. So this right here is going to be some x comma y. Our goal is to figure out what the y is. Right? So y equals 0.9 times what goes in here? X minus half of this, 230 squared. Well, if this is 230, what goes in there? 230 squared. So 5290. So plus 52900. But is it actually a 52900? No. It's whatever 0.9 times 52900 is. So times that by 0.9, and I get 47610. So by placing this number here, I actually added 47,610. So how do I fix that? Subtract 47,610. 65441. And I get minus 17831. So this right here is the point. 230, comma, negative 17,831. So If you build 230 units, so you're making airplane engines, you will lose $17,000. So that's not good. You probably want to make more than that. Otherwise, you're going to lose money. Or I guess you could make fewer than that. Okay, you want to see another one? All right, the exact same process. So y equals, I'm going to pull out 0.9. 0.9 times x squared minus, so I do 306 divided by 0.9, and I get 340. Plus, I'm going to leave a blank, minus 34590. What goes in my perfect square? X minus 170 squared. Do you get y? Okay. So 170 squared is 2890. 28900. Okay. So, should I subtract 28900 over here? Right, it's not actually 2890 because that 2890 is hiding underneath a 0.9. So I times this by 0.9 and I get 26010. So 26010. So I need to subtract 26010. And I get negative plus 34590 60600. So what we have here is a parabola, and this point right here says if you build 170 units, okay. Oh, I see. No wonder I was confused. This should be a plus. So 34590 minus 26010 plus 8580. So what this is saying is if you build 170 units, each unit is going to cost $8,580. So this is your answer. Yes. So it will tell you, so the problem will tell you C is the unit cost, so that's the Y value, and then X is the machines made. So if you build 170 machines, each machine will cost you $8,580 to build. Okay? All right. Does that make sense? Do you want to see another one? All right. Now, we're going to do something very dissimilar to those. Well, okay. There's a couple more we need to work on before we move on. All right, what do we do with a negative out front? Well, you pull out a negative 1. So I'm going to yank out a negative 1. So y equals negative 1, but I'm not going to write the 1. X squared plus 6x, leave a space, minus 13. Okay? What goes in here? Plus 3. And if a 3 is there, what goes there? 9. But it's not really a 9. It's a negative 9. So to undo a negative 9, I add 9 and I get minus 4. So this parabola is left 3 and down 4, and it's opening upside down. So what is the axis of symmetry? That would be the line that cuts the parabola into two identical pieces, and that is the line x equals negative 3. Right? And this one has a maximum. What is the function's maximum? The highest it ever gets is negative 4. So hopefully that one's pretty easy. All right. So here we have the equation of a ball that is thrown 5 feet. It starts 5 feet high, and we want to know, find all values of t for which the ball's height is 13 feet. So you're going to throw the ball, and eventually it's going to hit the ground. The ball started 5 feet high. When was the ball 13 feet high? So we're just going to plug 13 in here. So 13 equals 5 plus 23t minus 16t squared. Okay, so 0 equals, I'm going to subtract 13, and I'm going to rearrange this so it's in descending order. Negative 16t squared plus 23t minus 8. Do we really want to complete the square on this? Look how awful that would be. Let's start it and see what happens. So I need to pull out a negative 16. So 0 equals negative 16 times t squared. So I need to take 23 and divide it by negative 16. So negative 23 over 16t plus, leave a space, negative 8. Okay? So this would be negative 16 times t minus what? Half of 23 over 16. How do you cut a fraction in half? You double the denominator. So this would be 23 over 32. We having fun yet? So what would go there? 23 squared over 32 squared. Right? But it's not really 23 squared over 32 because it's hiding underneath a negative 16. So I would have to take this awful number and times it by negative 16 and then add the opposite of that here. So sometimes the equations are so nasty you don't want to complete the square. So we need another option. I'm going to teach you a new formula that you absolutely have to memorize, and you will use it next year so many times. Okay? It's called the quadratic formula. So put your pencils away and watch this. I will show you where the quadratic formula comes from, and then you can forget that. So completing the square is a series of steps. Divide out the leading coefficient, bump the constant to the other side, cut the middle term in half, figure out what the perfect square is, use that to find a new constant, times it by the leading coefficient, and then add or subtract that on the other side. We do those same steps every single time we complete the square. So if that's the case, we should be able to build a formula that will do all of those steps for us. And here's how we do it. We start with the equation y equals ax squared plus bx plus c. This equation represents every single quadratic possible, right? So let's complete the square on this, and that will give us a formula that will complete the square for us. So I'm going to move the C out of the way, and I'm going to pull out an A. And this is going to be really weird, and if you don't understand it, that's fine. So we get A times x squared plus b over a x, leave a space, plus c. Okay? So if those were actual numbers, like 5, 2, and 1, this is what I would do. I would move the 1 over, I would pull out the 5, and this is what I would end up with. Okay? So y equals a times, what goes inside here? Half of b over 2 of b over a. What is half of b over a? B over 2a. So this is b over 2a. Well, if that is b over 2a, what goes here? B squared over 2a times 2a, which is 4a squared. So if we had x squared plus 6x, leave a space, we would do x plus 3, right? So this becomes a 9, and then x plus 3 times x plus 3 equals those. Okay, but is this really a b squared over 4a squared? No, it's a times b squared over 4a squared, which is actually just b squared over 4a. So how do I undo b squared over 4a? I subtract b squared over 4a. Okay, but these need a common denominator. So I'm going to times this one by 4a over 4a. Okay, and that leaves me with 4a minus b squared, or 4ac, minus b squared over 4a. Okay, which is weird, right? So now we want to know when this equals 0. So let's move this over here. So we're going to add the b squared and subtract 4a. So I get b squared minus 4ac over 4a is equal to a times x plus b over 2a squared. All right, I need to divide by a. So this becomes a squared, a squared. And then I take the square root. So I get plus or minus the square root of b squared minus 4ac over, what is the square root of 4a squared? 2a. And that's equal to x plus b over 2a. So now I subtract b over 2a plus or minus the square root of b squared minus 4ac over 2a. And that creates this formula, which now, if I lost you, come back. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And that is the quadratic formula. Okay. What does that formula do? That formula completes the square. Okay. So if I had the equation y equals x squared minus 5x minus 24. In this equation, a equals 1, b equals negative 5, and c equals negative 24. I could complete the square to solve this. However, I could also just plug these in and that equation will do all of the work for me. Okay. So where does this equation equal 0? Well, let's plug it in. So negative b is going to be 5 plus or minus the square root of 5 squared is 25. And then I like to do all three of those at the same time. Negative 4 times 1 is negative 4 times negative 24 is 96 over 2 times 1 is 2. And I get 5 plus or minus the square root of 121 over 2. So 5 plus or minus the square root of 11, or sorry, not square root, 11 over 2. 5 plus 11 is 16 over 2 is 8. 5 minus 11 is negative 6 over 2 is negative 3. And that is where that quadratic crosses the x-axis. So that is the quadratic formula. So let's do some problems dealing with that. We don't want to do this one yet. Okay. So in order to use the quadratic formula, we have to have a 0 on one side. So 2x squared minus 5x minus 4 equals 0. So a is 2, b is negative 5, and c is negative 4. Okay? So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So let's plug those in. 5 plus or minus the square root of 5 squared is 25. And never put this in your calculator. What is negative 5 squared? It should be 25, but if I write it this way, the calculator is going to spit out negative 25 because the calculator does exponents before it does any of the other functions. So we need to put parentheses around that. And then I like to do all three of those together before I write anything down. So negative 4 times 2 is negative 8 times negative 4 is plus 32 over 2 times a is 4. So 5 plus or minus the square root of 25 plus 32 is 57. Now, this is called the exact answer. Okay? If it wants the exact answer, then you would just type in 5 plus the square root of 47 over 4, comma, 5 minus the square root of 57 over 4. Okay? But if it wants the decimal answers, you have to plug those in your calculator. So 5 plus the square root of 57 divided by 4, and 5 minus the square root of 57 divided by 4. Okay? Now, what if the answer is 6 plus or minus root 24 over 8? Well, this simplifies. 24 is 2 times 2 times 2 times 3. What can I bring out? A set of 2's. So 6 plus or minus 2 root 6 over 8. And this is important. Does that simplify? Well, the stuff on the inside of a square root cannot affect the stuff outside of a square root. So what we're asking is, do any of these have common factors? Yes, they all have a 2. So 3 plus or minus, so we pull a 2 out of that, we pull a 2 out of that, and we pull a 2 out of that. So root 6 over 4. And that would be the exact answer. The cool thing about the quadratic formula is it always works. For any given parabola, you can find the roots using the quadratic formula, even if they're imaginary. So if I had x squared plus 6x plus 30, so a is 1, b is 6, and c is 30. So the formula would be negative b plus or minus the square root of b squared minus 4ac over 2a. So that would be negative 6 plus or minus the square root of 36 minus 4 times 1 times 30 is negative 120 over 2. So that's negative 6 plus or minus the square root of 84 over 2. 84 is 2 times 2 times 2. Oh. Ah. No. 2 times 2. Okay. Times 3 times 7. Can I pull anything out? Oh, I just factored it. So 84 is 12 and 7, 4 and 3, 2 and 2. Sorry, I just skipped all that. So that would be negative 6 plus or minus 2 root 21 over 2. And then those can be simplified by 2. So negative 3 plus or minus root 21. Negative. Sorry. So this has an I in it. Negative 3 plus or minus I root 21, which means this quadratic does not hit the x-axis. So the quadratic formula will always work. Complete the square will always work, but a lot of times completing the square is really messy. And factoring only works if it hits the x-axis in a nice place. Okay, one more. No, this one. So let's go back to this problem. We want to know when in time does this equation equal 13? So I'm going to move everything to this side. 0 equals, I'm going to write this first, negative 16t squared plus 23t minus 8. If I can find the roots of this quadratic, that will tell me when in time the ball was 13 feet high, or whatever it is, 13 feet high. Okay? So, negative b plus or minus the square root of b squared minus 4ac over 2a. Do you have to memorize that? Yes, you do. So, negative 23 plus or minus the square root of, so negative 23 squared minus 4 times negative 16 times negative 8 is 17. Are you confused? No, you're right. So the formula says negative b. Got it? Over negative 32. Right? So I need to type those into my calculator. So negative 23 plus the square root of 17 divided by negative 32 is 0.589 seconds. And negative 23 minus the square root of 17 divided by negative 32 and 8.5 seconds. So when they throw the ball at 0.59 seconds, the ball has reached 13 feet. And then at 8.5 seconds, the ball has come back down and hit 13 feet again. Okay. Now, some of you might think, I don't need this assignment to pass the class. And that's probably true. However, you are going to be doing completing the square and quadratic formula a lot next year. A lot. So, you have today and tomorrow to finish this assignment. And then we'll have one more Friday, and that will be our last one. Okay. Well, I would work